Hi guys, welcome to our video of series called C# for Beginners. C# is a genuinely old language at this point, over 20 years old, and it keeps evolving, getting new syntax, new shortcuts, new ways of doing common things more concisely. Today's lesson is a tour of some of the newer features that have landed in more recent C# versions. Honestly, if you look at the code written 5 or 10 years ago, some of it won't use any of what we're covering today, but modern code bases lean on these features constantly and it's worth being fluent in them. Let's start with a problem going back to properties. Let's say we have a class named student and property public string name get and set, right? And we have student new oops new student and student dot name equals something like that. We can change whatever value whenever we want, right? Uh, Remember read-only properties from the class lesson. We could use a get-only property to lock something after the constructor, but that required extra setup and honestly was not always the cleanest way to say the set this one at creation and never again. Modern C# gives us a more direct way to express exactly that intent. Let's dig in. Instead of writing public string name get set, we're gonna say init and this one, and then as you can see it's showing a compile time error. Why? Because init-only property or indexer, okay? Public string here, public string name get init. Notice that instead of set we wrote init. This means name can be assigned once specifically during object creation and never again after that. So whenever initializing here, we should do something like here, that name equal Alex maybe. Okay, and console.writeLine student dot name. Okay. Here, remember object initializer syntax from the class lesson. We can still set it right at creation exactly like before. But try changing it afterward and it genuinely won't compile. Init in C# is saying that kinda this is set once at birth and stays that way forever without needing the extra constructor or boilerplate we used for read-only properties earlier in this series, right? Init-only properties give you that read-only guarantee, but with the convenience of object initializer syntax still fully working, genuinely at a nice middle ground, right? Okay, related problem here is with our student class right now, nothing actually forces you to set name at all, right? For example, if we create our student something like that, and let's see the output. Okay, let's see the output. Okay, it works finally, right? Without any warning, even though we probably meant for every student to have a name, nothing forced us to provide the name, real name, right? So the solution for that problem would be using the required keyword here and then just deleting this part, right? Public required string name, right? That required keyword changes everything. Now the compiler genuinely enforces that name must be provided whenever a student is created, right? Let's see, let's create. As you can see, it's showing error. Why? Required member student.name must be set in the object initializer or attribute constructor. So let's initialize it. And name equal Alex. Right. To summarize, required combined with init is a genuinely modern go-to combination for properties that absolutely must be set exactly once at creation, catching a whole category of bugs before your program even runs. Okay, shifting topics. Remember escape sequences and verbatim strings from way back, if I'm not mistaken, the basic types lesson. Let's revisit a genuinely annoying problem those did not fully solve. Let's say we have a JSON, right? String JSON equals, we should write something like that. JSON and then a new line, and then we need some kind of name, and then this sign, and after that this, and Alex, put like that, and then you're gonna need, oops, yes, it's right, and then new line, and age, and 25, something like that. A small chunk of JSON written as a regular string. Look at all those escaped quotes and new line characters. Genuinely hard to read and easy to get wrong, right? Modern C# gives us a much cleaner way to write exactly this kind of multi-line code-heavy text. Let me show you. String JSON2 equals 1, 2, 3, and then this one, name, maybe Alex, and age 25. Okay, console.writeLine JSON, console.writeLine JSON2. Let's run it. The same result, right? Three double quotes here, three double quotes, then our text spans multiple lines completely naturally, with regular quote characters, no escaping needed at all, and three double quotes again to close it. Yes, this is a raw string literal. Raw string literals are genuinely perfect for embedding JSON, SQL queries, or any multi-line text with lots of quotes, readable exactly as it looks, no more escaping headaches, right? Okay, next, remember creating arrays and lists using initializer syntax way back. Let's see an even shorter, more modern way. Let me show you. Integer array of integers, maybe old array equals new int 1, 2, 3, and then list int old list equals new list, maybe 1, 2, 3, 3, right? This is what we've been writing this entire series, and genuinely nothing wrong with it, right? Let's see other example. Int new array equals 1, 2, 3, and then a list of integers, new list equals 1, 2, 3, right? No new int or no new list integers at all. Just square brackets directly. This is a collection expression syntax, and C# figures out from the declared type on the left exactly what kind of collection to actually build, right? So this kind of new int or new list syntax don't need anymore. And they work completely normally after that. Same array, same list, just built with less typing. And let's combine collections with this syntax. Maybe int first equal 1, 2. Okay. Int second equals maybe 3, 4. Oops. Again, forgot. Okay. Int combined equals first, and then the second, and then 5 for each int, and in combined console.writeLine and And here's something genuinely powerful, that double dot before first and second. That's actually our next topic. Let's properly cover it, right? Collection expression syntax is just a shorter, more consistent way to build arrays and list same result, less ceremony. Let me show the output what I mean to prove what I mean. As you can see, we just kind of concatenating the arrays like we do with strings, right? Okay. Collection expression is just a so collection expressions with double dots, double points. We just glimpse it. Let's slow down and properly explain it. Let's use another example. For example, int again, and first equals maybe 1, 2, 3 this time, and then int second equals 4, 5, 6. Okay, two separate arrays, right? And int combined equals first and then second, right? Here, int array combined equals square brackets and dot dot first and comma dot dot second. The double dot dot before each array name is the spread operator. It means take every individual element out of this collection and drop them all in right here, rather than nesting the whole array as a single item, right? So if you see the output for each int I in combined console dot writeLine I. Let's see the outputs. As you can see, here's the concatenated or kind of combined array we are seeing. And the result is one single flattened array containing every element from both in order. And maybe let me show another example. For example, int with extra equal, maybe we have a 0 and then first, and then maybe 99, and then second, and then maybe 100. And let's see the output now. Combined, not with extra. Let's see the output here. As you can see, this array, and we can genuinely mix spread collection with individual standalone values all in same collection expression. 0 at the start, and then everything from the first array, then 99 inserted manually, then everything from the second array, and then 100 at the end. The spread operator is a really clean way to merge multiple collections together or insert one collection's content into a bigger one without manually looping and adding each element yourself. Okay, last topic for today, and honestly, this one might be my favorite modern addition. Remember constructors from the class lesson. Let's revisit that. Let me close the terminal. Okay, class, maybe student, and public string name get, only get public string age, oh, integer. Okay, integer age get public integer age, and then we're gonna have public student string name, and then int age name equal name, and age equal age. Right. This is exactly the pattern we learned a while back. Properties a constructor, and inside it assigning each parameter to its matching property, right? Genuinely, a lot of repetition, honestly, for something that's very simple. So instead of that, we're gonna create another class, maybe student 2, and then student 2 string name int age public string name get equal name public int age get equal age. Class student2 parentheses string name comma and int age right after the class name itself. This is a primary constructor. The parameters live directly on the class declaration and are immediately available to use anywhere inside the class, including right here, assigning them straight into our properties, right? And when initializing them, for example, student2 student2 equals new student2, maybe Alex, and 25 maybe, and console dot writeline student2 dot name and just here age, right? Creating one and using it works completely identical to before, same result, dramatically list boilerplate, right? And there's one thing worth knowing using parameters directly in methods too. Let me show the one example. For example, we have a class called greeter, and string name, maybe public void say hello, and then console dot writeline hello name. Oops. Hello name. And now greeter equal new greeter, maybe Sam, and greeter dot say hello, and genuinely, those primary constructor parameters are not just for properties. They are available inside any method inside our class, like name being used directly here inside the say hello without ever needing to store it in a property at all. Let me show you what I mean by showing the example. As you can see, hello Sam, but this function is not requiring kind of parameter for name. It's just directly grabbing the value that's coming from the primary constructor of our class. That's one of the useful things whenever you want to use the kind of variables without creating the property for them. And the summary point for that is primary constructor let you skip writing an entire separate constructor block for the common case of take these parameters, use them to set up the object. Genuinely one of the more impactful readability improvements in the recent C#. Alright, let's close this out, combining today's features into one clean modern class. Maybe class product string name double price public string name get public string name get equal name public double price get price public required string SKU and get and init. Okay, a primary constructor for name and price plus a required init-only SKU property that must be separated at creation and never changed after. And we're gonna have product array type products equal new product laptop, and then SKU equal maybe lap and 1000001, right? A new product, maybe mouse 25 SKU equals maybe mao and 002. Okay. And using collection expression syntax to build our array with each product, combining the primary constructor called for name and price and object initializer syntax for that required SKU. And we're gonna have for each var pro in products console.writeLine per r.name pr.name and pr.sku and $sign, and here product.pr.price. Okay. And looping through and printing each one's output, right? Let's see the output. Laptop lab 001 $1,200 and mouse mouse 002 $25. Primary constructors, there's the things we've used here is primary constructors, required properties, init-only properties, and collection expressions all working together and genuinely showing that what a modern concise C# class looks like compared to what we wrote several lessons ago, right? So that's all for today's lesson, and your challenge would be building a book class using a primary constructor for title and author with a required init property for ISBN. ISBN is kind of unique code for the books, or you can call it ID or whatever you want. Create an array of a few books using collections, expressions, syntax, and use the spread operator to combine it with a second array of books into one final list. Okay. So summary of today's video is, today we covered init-only properties for locking values after creation, and required properties for enforcing that something must be set, raw string literals for clean multi-line text without escaping, collections expression syntax for shorter array and list creation, the spread operator for merging collections together, and finish it with primary constructors for dramatically less constructor boilerplate. These features genuinely make everyday C# code shorter and more readable, and you'll see them more and more in modern codebase and tutorials going forward. Next time, we are covering type conversions, implicit and explicit, casting, and safely converting between types. See you there. Take care.